We're in TechMath 2. And we're going to do sections 8.5 and 8.6 today. And section 8.5 has to do with multiplication and division of radical things. Okay, so it looks like we have one lousy new rule. Only one? That seems hardly be worth the time, right? Yep, only one. All right. So if I have the nth root of A times the nth root of B, then I can write that as the nth root of A times B. And if I have the nth root of A divided by the nth root of B, then I can rewrite that as the nth root of A over B. But in any event, B can't be 0, so that would be the name of that too. All right. Questions about that? And again, once we get to imaginary numbers, all these rules will change a little bit because imaginary numbers are a little different than regular numbers. And also, we don't want to divide by a radical guy. So if I do, then I'm going to have to rationalize that denominator somehow in order to be in compliance with the 8th grade Common Core standards that are out there. So is it 8th grade Common Core? Yeah, it probably is. But maybe it's 7th grade Common Core now. But that would be the whole idea. Okay. So I'll look at problem number 1. And I see that I've got the square root of 3 times the square root of 6. And I'd call that the square root of 18. But I would recognize that as the square root of 2 times 3 times 3. So I'd really call that 3 the square root of 2. So 3 the square root of 2 would be my final answer. And I might even go as far as in the very first step, saying it's the square root of 3 times the square root of 3 times the square root of 2, and then just 3 the square root of 2 without any of the other stuff. And I did bring my calculator today, so we'll see what my calculator thinks about this whole thing. So if I go square root of 3 times the square root of 6, and I get 3 square root of 2 right out of my calculator, so isn't that convenient? Okay, we'll do number 3 next. And I've got the third root.
On the TI-89, how do you put in a root on TI-89?
You probably have to put parentheses to the 1/3 if there's no root key. Is probably the way you have to do it. Yeah. Or the math part of the calculator is probably a multiple root thing. I don't think they would have taken that away from you. Anyway, back to the problem. Third root of 4 times the third root of 18. So I recognize that as the third root of 2 times the third root of 2 times the third root of 2 times the third root of 9. And then I could just write 2 and the third root of 9, and I'd be all set. But again, my calculator ought to better do that for me. So I could go second function root. That didn't do me any good, did it? Clear. Second function, boom. It's giving me answer. Why would it do that? Boy, that's pretty funny, isn't it? But if I went... Oh, okay. Okay, I see what they want me to do. Okay, so third second function root. Okay, third second function root of 4 times times the other times key times third root of 18. Boom. And that gives me a number, 4.16. So that didn't keep it in root stuff. All right, but there's nothing wrong with 4.16. That'd be perfectly okay for an answer too. I mean, but there's my final answer. But there'd be nothing wrong with that answer if I were to see that. All right, we'll do number 6 next. The third root of 32 divided by the third root of 4. So I would rewrite that as the third root of 2 to the 5th divided by the third root of 2 squared. And then I'd say, well, that's the third root of 2 to the 5th over 2 squared, which is the third root of 2 cubed, which is 2. And I probably would have skipped that out a long time ago. I probably would have said 4 goes into 32 8 times. The third root of 8 is 2. I probably would have skipped out and done it that way. Okay, doing number 12. And I didn't put that in my calculator. I don't know what my calculator do. Anyway, square root of 12 times the fourth root of 9. Fourth root of 9. Well, that looks like, what are we going to do about that? So this is 2, the square root of 3, times the square root of 3, right? So the fourth root of 9 would be the square root of 3, would it not? I say fourth root of 9. So I got 3, I got 3 squared to the 1/4 would be 3 to the 1/2, which would be the square root of 3. All right, so that'd be fine. So that's the 6. Looks like 6. All right, so I got the square root of 12 times the fourth root, the square root of 12 times the fourth root of 9. Boom, 6. Yeah, very good. Thank you, calculator, for confirming that. Okay, number 13. The square root of 3 over the cube root of 3. And we need to go and rationalize the denominators. Okay, so I'd multiply this by the cube root of 9 over the cube root of 9. And then I'd have square root of 3 cube root of 9 divided by 3. And then I'd say, well, okay, so I've got 3 to the 1/3 times 3 to the 2/3 divided by 3. Oh, it looks like 3 over 3, which is 1. 3 over 3, which is 1. Okay, well, let's see. The square root of 3 divided by the third root of 3. The third root of 3. Boom. Very interesting. I don't get 1.
What do you get? 2?
I get 1.2.
In the book it shows under 13 it shows
Not 1.
no, it shows
Yeah.
Square root of 3.
So the issue is number 13 is totally wrong. So now the problem is, what did we do wrong to make it that way? Okay, so number 13, because my calculator did not say the answer was 1. Okay, so I got square root of 3 over the cube root of 3. Okay, so this is 3 to the 1/2 divided by 3 to the 2 by 1/3. So that'd be 3 to the 1/2 minus 1/3, which would be 3 to the 1/6. 3 to the 1/6, which would be the 6th root of 3. Which is 1.2? Which is 1.2. Now the issue is, I cheated, right? We're in section 8.5. In section 8.5, I'm supposed to be doing it with radicals, and I went to fractional coefficients to get the right answer, okay? So now the issue is, can I do that without cheating, with being faithful to the section that I'm in? Okay, so I got the square root of 3 divided by the 3rd root of 3. Okay, and I'm going to rationalize the denominator and call this the 3rd root of 3 squared divided by the 3rd root of 3 squared. And then I'm going to have the cube root, the square root of 3, cube root of 3 squared divided by 3. Okay, so that's what I've got. Now, the square root of 3, let's look at the square root of 3. Square root of 3, square root of 3 is the same as the cube root of what? Square root over 3, no, 3 the square root of 3. 3 the square root of 3 is the same as the cube root of 3 to the 4th. Okay, so that's that. So the square root of 3 is equal to the cube root of 3 to the 4th over 3. Okay. Okay, so now I can come back here and say this is equal to the 3rd root of 3 to the 4th times the cube root of 3 squared divided by 3 squared. Okay, and then I can have the cube root of 3 to the 6th divided by 3 squared, which is 1. I did it again. I got the same wrong answer all over again. All right. So, cross that out. Whatever we're doing there, we're not doing that right. All right. So maybe we just have to not be faithful to the section and get the right answer. Square root of 3 over the cube root of 3. We'll do something really silly. We'll look in the back of the book. Oh, look at this. Look at example 4 on page 294. What do they do? They go into fractional exponents just like I did. So going to fractional exponents is being faithful to the section we're in. Okay, so no problem. This is This is 3 to the 1/2 divided by 3 to the 1/3, which is equal to 3 to the 1/2 minus 1/3, which is equal to 3 to the 1/6, which is equal to the 6 root of 3, and final answer. And I am being faithful to the section I'm in. Everybody's fine now with that. Okay, good. And I couldn't do it the other way because it can't be done the other way. That's the problem there. I'm probably messing up order of operations or something. Okay, well that was good. I'm glad I figured that one out. Number 18. 6 minus the square root of 3 times 5 minus the square root of 3. Well, if this were a minus b times c minus d, you'd know how to do it, right? So that's all it is. So 30 minus 6 the square root of 3 minus 5 the square root of 3 plus 3. 33 minus 11 the square root of 3. And we're done. That's as far as we need to go. See if my calculator gives me that. Parentheses 6 minus the square root of 3, close parentheses, times parentheses 5 minus the square root of 3, close parentheses, boom. Yeah, it does. 33 minus 11 the square root of 3. Isn't that great? So you put minus 11 the square root of 3 first, misspelling the math because you wouldn't put a minus sign first in a situation like that. But other than that, everything's fine. All right, we'll skip down to number 24 and do it again with not numbers. (24) 3a minus square root of ab. Now this guy I can't put in my calculator because I didn't pay enough for it, minus. But Raimundo did give me one of those new TI-inspired calculators, and I haven't figured out how to use it yet. But someday I'll think about it. Okay, so assuming I wrote the problem right, I got 6a squared. I got plus 9a square root of ab. I got minus 2a square root of ab. And then I got a minus 3ab. All right, well, that seems all right. And bringing like terms together, 6ab minus 3ab plus 7a square root of ab. All right, well, that seems okay. We'll drop down to 40. Uh, 4 minus square root of 6 divided by 2 plus 4 the square root of 6. Now, the math we got to remember is that a squared minus b squared is a plus b times a minus b. So what we do is we get the conjugate of a plus 4 the square root of 6 to rationalize the denominator. So we go 2 minus 4 the square root of 6. And now we're in the form a plus b minus a minus b, and we end up with just a squared minus b squared on top. 2 minus 4 square root of 6. All right, so on the bottom I've got a 4, and I've got a minus 16 times 6. 16 times 6. 16 times 6. 96, I knew that. Minus 96. And then on the top I've got an 8. I got a minus 16 square root of 6. I got a minus 2 the square root of 6. And I've got a plus 4 times 6, which is 24. Alright, so on the bottom I've got, I do a squared minus b squared. Yeah, that's what it is. So I got a minus 92 on the bottom. and I got a 32 on top, and I got a minus 18 square root of 6 on top. And then I say, well, it looks like 2 goes into everything. So 2 can go into there 16 times, into there 9 times, into there 46 times? 46 times. And then I say, none of those are divisible by anything else. So I'm done with my final answer. 16 minus 9, the square root of 6, over minus 46. Now, I'm pretty sure my calculator is going to be able to do that for me, but it might just give me a number. Let's see, 1, I need a parentheses, 4 minus the square root of 6 divided by, parentheses, 2 plus 4 times the square root of 6. Oh, very nice. So my calculator gave me 9 square root of 6 minus 16 over 46, which is the same as that guy there, except I don't have a negative in the bottom. So that'd be a reasonable thing to do, multiply top and bottom by -1. So thank you, calculator, for giving us the right answer. We're going to 45 next. Oh, 45. Looks like a pain, does it not? 45. Square root of 3 plus the square root of 5 divided by the square root of 3 minus the square root of 5. Okay, so we're going to multiply top and bottom by square root of 3 minus the square root of 5. I think that's what we have to do. Square root of 3 minus the square root of 5. Okay, so on the bottom, we end up with 3 minus the square root of 5. And on the top, we end up with the square root of 3 plus the square root of 5 times 3 minus the square root of 5. Okay, so that looks all right. And then we're going to rationalize the denominator, so we're going to multiply top and bottom by 3 plus the square root of 5. All right, so isn't that lovely? So on the bottom, I've got a 9 minus 5, which is a 4. So I got a 4 on the bottom. On the top, I have square root of 9 minus 5 times 3 plus the square root of 5. All right, well, that's 4. Square root of 4 is 2. 2 goes into 4 twice. So I'm going to have 3 plus the square root of 5 over 2. Well, that was all right. Let's see if my calculator does that. Clear out of there. Square root of 3 plus the square root of 5 divided by square root of 3 minus the square root of 5. And when we get done, we want the answer we have. And my calculator gives me a 2.618. 2.618. And so 3 plus the square root of 5 divided by 2. Way to go, stupid calculator anyway. Yeah, 2.618. So that's right. Yeah. Excellent. So again, if you put it in your calculator and came up with 2.618, I'd go and count that, right? And then probably take off 0.1 for significant digits, right? Yeah, because I'm that type of guy. All right. Now we're going to move on to section 8-6, and we're going to solve for x. So that's our plan. Our plan is to solve for x. All right. And we remember that if we have x squared is equal to a, then x is going to be plus or minus the square root of a, right? Because it could be either of those when I square it to get a back. Okay, so we're going to remember that just on the side. Okay, starting with number 1, and I have the square root of x minus 4. The other thing that's going to happen is I'm going to end up with solutions that are wrong. And I'm going to have to check my solutions in multiple solution cases because it may be that I have a wrong solution. Okay, well anyway, we're going to square both sides of this equation. X minus 4 is 49. X is equal to 53. All right. 53 minus 4 is 49. Square root of 49 is 7. Looks good to me. All right, so I got number 1 right. And there's only one solution, and I checked it. Okay, number 3. Square root of 3 minus x, 2x minus 3. Okay, we're going to square both sides of the equation. 3 minus x equals 4x squared minus 12x plus 9. 4x squared minus 13x plus 6 is equal to 0. Okay, how many think that I did that right? Yeah, I don't see any hands out there. Is that better? 3 goes over there, make it positive. 6, x goes over there, add 1, make it 11. Okay, now, okay, is that something that's factorable? If I had 2x and 2x, and I had minus 3 and minus 2, minus 3 minus 2, I don't get there. Okay, but if I have, how would you like to factor it? If I had 4x and an x, and I went minus 3 plus 2, that doesn't work either. You sure this factors? Huh, what does it factor as?
4x minus 3 and x minus 2.
4x minus 3, x minus 2. But that's, oh, okay, so there's 8 plus 11, okay. Excellent, so we factored it, equals 0. Too early in the day. So x is going to be 3 over 4, or x can be 1 over, no, 2, or x can be 2. So those are my possible answers. I go back and I'm going to check them. Alright, so if x is 2, I've got the square root of 1, which is 1. 1 is going to equal, if x is 2, that's going to be a 4. So x is 2, x equals 2 works. Alright, now I'm going to try 3 over 4. 3 over 4, really? Yeah, 3 over 4. So I'm going to try 3 over 4. So if 3 minus 3 over 4 would be 9 over 4. The square root of 9 over 4. Is that equal to 3 over 4? 3 over 4, so that'd be 3 over 2 minus 3. And that'd be minus 1, 3, 1 and a half, right? And that's a giant no. It's not equal to that. Or is it? No, it's not equal to that because this is 3 over 2, and that's, wait a minute, 3 over 2 is equal to minus 3 over 2, right? Yeah, sure it is. So no, it's not, because minus 3 over 2 is not equal to plus 3 over 2. So the bottom line is that answer, boom, doesn't check. So that's where because I squared both sides of the equation, I added a solution that wasn't really there, and now I have to remove it. That's why I have to check my work. Okay, moving on to number 6. That clear as mud? Yeah, I'll put it in English.
You should have said that in 8th grade now.
Huh?
So it makes sense now.
Yeah, it didn't make sense in 8th grade, but it makes sense now.
I knew I had to do it. I knew how to do it, but I didn't know why.
Why? Why you had to do it? Okay.
Why
Well,
I didn't check them.
You didn't, yeah. Yeah, you have to check them because as soon as you square something, you have the potential of putting another solution in. Yeah. So that's why. That 8th grade math. My 8th grade math instructor served in World War II, so he was really good. He only gave me a B though. Told you about that, right?
You just did.
Yeah. I never got any problem wrong for the whole 8th grade. Every single test was 100. Every single homework was correct. I got a B because I didn't follow the instructions. The instructions were do your work in pencil. Well, I didn't make mistakes, so I did my work in pen because I don't make mistakes. Now, how could it be that I didn't make mistakes? Well, 8th grade math is really simple, right? So that's one reason. But I had a small chalkboard that I used when I did my homework, and I did it on the chalkboard first, and then when I got it right, I put it on my homework paper. And that process made it so that the homework was always right. Getting all the tests correct had to just be dumb luck, right? That's the way it is. All right, I'm sticking to my story. Number 3. Okay, so I got this problem. Okay, I'm going to go and divide both sides by 3. The cube root of x minus 1 is equal to 4. And then I'm going to go and cube both sides of the equation. So I've got x plus 1 is equal to 64. So x is going to be equal to 65. No, it's not. X isn't going to be equal to 65. X is equal to 63. Okay, now I only have one answer, but I'm going to go back and check it anyway. So 63 plus 1 is 64. The cube root of 64 is 4. 3 times 4 is 12. And it checks. Yeah, that always infuriated me too when I had instructors that told me to do things but never told me why. Because I told you so, kid.
Yeah.
Square root of x squared minus 4x plus 29 equals 2x plus 1. All right, so my plan is to get rid of the square root. I'm going to square both sides. I'm going to have x squared minus 4x plus 29 is equal to 4x squared plus 4x plus 1. Okay, so I'm going to have 3x squared plus 8x minus 28 is 0. Okay, did I do that right? Yes, I probably did. Okay, so now the issue is, can I factor that? 3xx. Okay, now the 28 could be a 2 times 14, or it could be a 4 times 7. Okay, so 4, 7. 4 times 3 times, I don't think that factors. Oh, 2 and 14. 2 and 14 works. minus 14 plus 2. No, it doesn't. Plus 14 minus 2. There, that works. I've got 14 minus 6 giving me 8. Alright, so I've got an answer that could be 2 or could be minus 14 over 3. Okay, now I got to go back and check both of those answers because I'm pretty sure I'm going to have to get rid of one of them. And so, anybody remember what problem we're working? 12. Okay, so I've got square root of x squared minus 4x plus 29 is supposed to be equal to 2x plus 1. So if x were 2, I'd have the square root of 4 minus 8 plus 29 would equal 5. Yeah, that checks. Does that check? Yeah, that checks. Now this 14 over 3, minus 14 over 3. Alright, so I got the square root of 14 over 3 squared minus 14 over 3 plus 29 is supposed to equal 2 times minus 14 over 3 plus 1. Isn't that convenient? Alright, so this is square root of, anybody know what 14 squared is? Well, we'll just leave it that way. So I got 14 squared over 9 plus, what's 14 times 9? 14 times 9, 126. 126 over 9 plus, what's 29 times, no. I already have a 3 there, right? So I only have to multiply 14 times 3, which is 42. 42. Okay, and then I need 29 times 9 is 261. Okay, so I got 261 over 9, and that's supposed to equal 28 over 3 plus 1, which would be, this would be 3 over 3, so it'd be minus 25 over 3. So on top here, I should have, now I don't have to go any further, because it can't be equal, because I got a minus sign on this side, and there's no minus sign on the other side, so that can't be equal, and my solution isn't there, and I can get rid of it. I suspected that would be the case, and that was the case. Okay, well, did I do 13? No. Okay, so I'm supposed to do 13, so I better hurry up and do 13. Square root a squared minus 5a plus 20 is equal to 4a. Okay, I'm going to square both sides of the equation. A squared minus 5a plus 20 is equal to 16a squared. I've got 15a squared plus 5a minus 20 equals 0. And I think about factoring that. And 3a, 5a, 5 times 4, 4 times 5 times 3. Okay, so if I go minus 4 minus I go plus 4 minus 5. 20 minus 15. Okay, so there we are. So A is going to be solution set minus 4 over 3, and minus and plus, the other minus, plus 1. Okay, I put the 1 in, and I see that the 1 checks. All right, so 1 checks. So now, can I make 15 times minus 4 over 3 squared plus 5 times minus 4 over 3 minus 20? Can I make that equal 0? Although it'd be better, I better not do that because I have to go back to the original equation. Silly me. Alright, so the original equation, can I make, oh, we better go back and check 1 again in the original equation. So I put 1 back in the original equation. 1 and 1 makes it 16. The square root of 16 is 4, which is equal to 4. So the original equation does say that the 1 guy still works, because I checked him in the wrong spot. Okay, so I'm looking at the square root of minus 44 over 3 squared minus 5 times minus 4 over 3 minus 20 plus 20. Plus 20 okay, that's all right. Thought I did something wrong. Is supposed to equal 4 times minus 4 over 3. Now, we know it can't be. The square root guy always going to have to give me a positive number. This is a negative number, so this can't be equal. That can't be a solution. Okay, so I got 2 minutes to do problem number 29. Oh, that shouldn't be too bad. So problem number 29 has to do with a pendulum swinging back and forth, boom, boom. And the period, number 29, the period of the pendulum is 2 pi, the square root of length over g. Which begs the issue, I've got a grandfather's clock in Council Bluffs, and it's keeping perfect time. Okay? And I take it over to Omaha. Is it going to keep perfect time in Omaha? No, it's not going to, because the length is the same, but I change gravity between here and Omaha. So you think of gravity is equal to 9.8 meters per second squared. Gravity is equal to 32 feet per second squared, right? Those are the things that you were taught in 9th grade science, right? But if you look in the Handbook of Chemistry and Physics, it gives you gravity out to 10 significant digits depending on what latitude you are on the Earth. So depending on the rock formation under you, how high up you are in the mountain, how far you are in Death Valley, will depend on what your G is. And in fact, that's how we measure G. We go and we have a pendulum going back and forth of a known length, and we calculate G for that location. So that's how you'd measure the gravitational constant in that location. Anyway, so back to the problem. We want to solve for L. Okay, so P over 2 pi is equal to the square root of L over G, and we square both sides of the equation, and we say G is equal to, because I'm going to cross multiply, L times 4 pi squared over P squared. And that's how we would calculate gravity at any location. So back in the 17th, 18th century, when we were going around trying to figure out what gravity was after Newton told us about it, then we could just, you have a known length of the pendulum, and you can measure the amount of time it goes back and forth. You can come up with G to a couple significant digits. Okay, questions? Thoughts? Comments? For those that came in late, I did sing the fourth verse of the song, and you missed it. But I did come up with what those words were.